There are 4 ways to prove that a quadrilateral is a parallelogram. This is method 4, which is prove that the diagonals bisect each other. Okay, let's explain what that means. Diagonals are the lines that go from one vertex to another when those two vertices, okay, that's the plural of vertex, when those two vertices are not next to each other. So LN and MO would be my two diagonals here. Okay, bisect means cut in half. If I want to know where they're cut in half, that's going to be the midpoint. Okay, so for method 4, you're using the midpoint of your diagonals. The diagonals here are LN and MO. Okay, essentially when you find the midpoint, you're just finding the average, the middle. Okay, so all you're doing is adding your two x values, dividing by 2. Adding your two y values, dividing by 2. You cannot put this whole thing in the calculator. There's no comma or anything like that. You need to enter this as a fraction, get your answer. Enter this as a fraction, get your answer. Okay, so let's see how it works out. For Ln, I'm going to add my x's. So -2 plus 2, that's over 2. Okay, always over 2, don't forget that part. Add your y's and put it over 2. So 3 plus a -2. Okay, unlike slope and distance, this is a plus sign here. So you're not going to do minus a negative and all that stuff. Okay, these are pluses here. All right, -2 plus 2 is 0 over 2. Doesn't matter, it's still 0. Okay, 3 plus -2, that's 1 over 2 is just 1/2. Okay, now if these are going to bisect each other, okay, Ln and MO, if they are cutting each other in half, that means that they need to have the same midpoint. Okay, so let's see if they do. M and O are here. Plugging them into the midpoint formula. Add your x's. x1 plus x2. 4 plus -4 over 2. Add your y's. 3 plus a -2 over 2. Okay, 4 plus -4 is 0. Over 2 is still 0. 3 plus -2, okay, I can see that's the same as this. 3 plus -2 is 1. Over 2 is 1/2. So yes, they have the same midpoint. That means they cut each other in half at the same exact point. That is it for method 4.